Now see the working of full wave rectifier using two diodes. I have rigged up the circuit diagram. So these two sources are actually the secondary of the transformer. So this is a center tap terminal, so which is put as ground over here. You can see this is diode D1, D2, and this is the load resistor. Suppose we now simulate and see the output waveform. This is how it looks like. So let me delete this half wave rectifier. So this is the output waveform. So let me also see the input signal. So as you can see here, so since I not labeled the lines, so it is coming in the form of node number, that is V of N002 and V of N001. So let me go back to the circuit and then insert the nodes. Now I have modified the circuit by inserting two nodes, that is input and output nodes. So let me again run the program. Let me see the voltage here. Now it is input. Let me remove this VFN because it is on. Now this is input. Let me also see the output here. So this is the output. So as you can see here, so there's a difference of again VD on at the when diode which diode is conducting now. Okay, diode D1 is conducting during positive half cycle of the input voltage. During negative half cycle of the input voltage, this is conducting. So we have the negative half cycle is to get inverted at the output. And we shall insert a capacitor and try to see how does the circuit behaves. So let me insert a capacitor here that is coming in parallel with this load resistor. Now here we have inserted a capacitor. Let me give the value of capacitor as some 50 microfarads. The value of R is, let me make it visible properly. This is 1K with a capacitor C1 with the value as 50 microfarad. Let me run it again now. Now you can see this is charging. This is at T is equal to 0 because it went along with the input voltage till the peak. Now it is discharging slowly. Again it charges, again discharges. You can certainly measure the ripple voltage of this particular output waveform by clicking on the output waveform button. This is the peak, this is the minimum most signal. So I can just zoom that further to actually, okay, this is almost at the, now the difference of the voltage is 130, it's almost, 1.34 volts. So this is the output voltage you are having. So you have a pretty large ripple voltage. It's almost 20% of the output voltage. So you have, this is around 9.2 volt. It's almost 15 to 20% of the voltage. It's around 15%. So if you want to further reduce the ripple voltage, the possibility is you have to increase the value of C. Suppose if I increase the value of C by 50 to 200 microfarad, so let me again simulate, the ripple voltage will change. Now again let me zoom this portion and then try to identify the maximum and the minimum voltages. See, now it's almost 378 millivolts. So it's hardly 33% of that voltage. So this is 9.2 volts is the peak voltage. So 230, almost 400 millivolts is the output ripple voltage. So likewise, by changing the capacitance value, we can reduce the ripple voltage. So we can certainly verify the theoretical value and the practical value of the ripple voltage by using the equation. For Fourier rectifier, we know that it is Vp, that is V peak minus Vd by 2f into Rc. So where f is equal to 50 Hz uh, and R is equal to 1K in this particular case, and C is equal to 100 microfarad. Using that equation, we'll get the value of V ripple, which is theoretical value. You can certainly verify that with the simulated value. Now we should see the construction of Fourier rectifier using the bridge circuit. So let me start from the beginning. So let me select a new schematic. So let me have the bridge connected. So let me have 4 diodes. So this is diode 1, 2, this is third, here is the fourth diode. Let me have a resistor here, and let me have a source. So source, you can go to F2, then get a source, LP source, because what a peak voltage up, so maybe 10 volt. So this is, so the input voltage is connected to this junction.